Something odd just happened in the orbit, and it caught everyone by surprise. A small mark on China's Shenzhou Capsule created worry among technicians, leading to a rushed launch. What really touched that spacecraft? Why did China react so quickly? And what does it mean for the crew living on Tiangong right now? How plans changed in orbit. On the 1st of November, 2025, a new crew reached the Tiangong space station on a Shenzhou spacecraft. The new team arrived to take over work from the crew already on the station. The crew who were due to return had been in space for some months. Their names were Chen Dong, Chen Zhongrui, and Wang Jie. They were scheduled to come home on the 5th of November, 2025, in their original return capsule. Those on the ground checked every system before the trip back home. They reviewed life support, power, the heat shield, and the parachutes. Cameras and sensors that look for damage were used. During these checks, technicians detected a crack in a small viewing window of the Shenzhou 20 return capsule. It was a small crack. Safety rules say even a small crack can make a capsule unsafe for a crewed return. That rule exists because reentry is the hardest part of a mission. The capsule must face extreme heat and strong pressure. A weak spot can let air leak or let heat damage the inside. For this reason, managers do not take risks with crewed returns. When the window failed the checks, leaders had to change plans quickly. The decision was made to use another capsule to bring the crew home. The newly arrived Shenzhou 21 craft was available. They moved quickly to prepare it for an earlier return. The 3 astronauts moved to the newer capsule and made the final checkup. On the 14th of November, 2025, they returned to Earth and landed at the Dongfeng site in Inner Mongolia, and officials reported the crew in good health. Swapping capsules is not simple. Each capsule has its own checks and fittings. Flight controllers on the ground worked with engineers to update the timeline. Medical staff watched the crew for stress and any signs of sickness. Every connection and seal was tested again before reentry. Leaving the damaged capsule at the station created another problem. The crew that remained at Tiangong then lacked a ready backup for return. Chinese flight rules require a usable return capsule to be available for station crews. To restore that safety margin, leaders prepared an unmanned mission to bring supplies and a spare ship. Hardware for a new uncrewed launch was ready at the Jiuquan Satellite Launch Center. Engineers shortened the usual checkout time and prepared a Long March rocket. The uncrewed Shenzhou 22 launched on November 25, 2025. It carried spare parts, testing tools, and fresh supplies. The cargo helped them examine and work on the damaged capsule. This series of moves showed how one small defect forces big actions on the ground. It also showed how they keep a rule that no one returns in a capsule that fails safety checks. The quick steps taken by engineers and flight controllers removed immediate danger for the crew that came home. Even so, the story was not over. More checks and decisions waited. What came next would test repair plans and the limits of current tracking systems. The team on the ground held quick meetings to agree on the steps. Engineers ran more tests on the capsule while doctors watched the crew. Cameras on the station sent close shots of the window. Pressure sensors inside the cabin were checked every minute. The China Manned Space Agency led the review. Managers worked with teams at the Jiuquan Satellite Launch Center. They looked at 3 choices, which were to repair in orbit, swap capsules, or send parts up fast. The swap option won within days. That choice showed the value of having spare ships ready on the ground. Still, many questions remained. Could a repair last through reentry? But as teams searched for answers, one detail emerged so quietly and so dangerously that it changed everything. What were they overlooking? The small crack that stopped the trip. Technicians checked the Shenzhou 20 capsule before its return window. They used cameras, close-up photos, and pressure gauges to inspect the descent module. During these checks, they detected a hairline crack on a small view window. The crack was tiny in size but large in consequence. The China Manned Space Agency said the damage made the capsule unsuitable for a crewed return. What does a window do on a return capsule? The small glass near the crew serves 3 jobs. It provides a view for the crew and for cameras. It helps some instruments see outside. Most importantly, it keeps the cabin sealed so air and pressure stay inside. During reentry, the capsule faces high heat and heavy pressure. Any weak point can lead to a leak or worse damage. Spacecraft windows are built from tough, heat-resistant materials. On many spacecraft, engineers use fused quartz or layered glass that handles high heat. These materials hold up to temperature and pressure better than normal glass. Official Chinese reports did not detail the exact material used on Shenzhou 20. That said, engineers prefer materials that resist heat and that expand little when heated. Those traits lower the chance that a tiny flaw becomes a big break. How can such a crack appear? One likely cause is a small impact from space debris. Space debris includes old rocket parts, broken satellite pieces, and tiny fragments. Some pieces are large and tracked by radar. Many pieces are tiny and hard to see. A small fragment moving at orbital speed can hit with great force. Even a tiny hit can leave a hairline crack. After the crack was seen, engineers ran more tests. They checked the seals around the window. They measured cabin air pressure for any slow loss. They reviewed camera shots from several angles. Flight controllers compared the capsule images to earlier photos to see when the crack began. Engineers also checked space object lists to see if a known piece had passed nearby. Those lists did not show a clear match. That outcome shows small debris can slip past trackers. Repair work in orbit is difficult. Patching a view window must survive high heat later. A simple tape or glue cannot keep out heat and pressure during reentry. Any repair must hold the seal and resist the heat that builds around the capsule. For that reason, managers judged a quick repair risky without full testing and the right tools. Moving the crew to another capsule solved the immediate danger. The Shenzhou 21 descent module was prepared early for the swap. The crew moved to the fresher capsule after more checks were done. They later returned to Earth safely in Shenzhou 21. Meanwhile, the damaged Shenzhou 20 stayed docked to the station for closer study. The incident shows the limits of current tracking for small fragments. Sensors, cameras, and routine checks kept the crew safe by catching the crack before reentry. Engineers used all the data they had to weigh the options. They chose the path that reduced risk for the people on board. What happens next to the capsule will depend on deeper inspections using tools and parts sent up by the uncrewed Shenzhou 22 mission. Engineers will decide if a proper repair is possible. If not, the capsule may be prepared for a controlled fall into the Pacific Ocean so it does not pose a risk to people on the ground. Officials will publish formal results once testing concludes for the public record. But as engineers braced for the next step, a far bigger decision loomed, one that could reshape China's entire mission strategy. What hidden risk forced their hand? What China did next? After the inspection showed the crack, leaders had to act fast. They had to keep the crew safe and the space station secure. The first step was to bring the older crew home. Chen Dong, Chen Zhongrui, and Wang Jie moved into the Shenzhou 21 return capsule. A capsule had to be prepared earlier than planned. They ran extra checks on life support, parachutes, and the heat shield. Medical staff monitored the crew while engineers signed off on systems. The 3 astronauts returned to Earth safely. They landed at the Dongfeng site in Inner Mongolia and were reported to be okay. Bringing them home solved the urgent safety issue. However, the station crew needed a ready return capsule. Rules say a usable return craft must be available at all times. With Shenzhou 20 left docked and unsafe, officials planned an uncrewed mission. Hardware for a new mission was ready at the Jiuquan Satellite Launch Center. A Long March 2F rocket stood by, and the Shenzhou spacecraft was prepared. Engineers shortened the usual checklist to speed up the launch safely. Technicians focused on the most important tests and cross-checked parts. On November 25, 2025, China launched an uncrewed Shenzhou 22 to Tiangong. The mission carried spare seals, testing gear, repair tools, and medical supplies. It also brought fresh food and other items to support the crew on station. The ship reached orbit and docked at the Tianhe Core Module forward port. Controllers watched docking cameras, sensor readings, and telemetry in real time. They followed strict checklists before they opened any hatches or moved cargo. No new astronauts flew with this launch to avoid adding risk. The uncrewed flight served two goals. First, it restored a ready return craft. Second, it delivered the tools needed to inspect and possibly repair the damaged capsule. Robotic arms and crew tools would help with close photography and repair trials. Engineers planned to test any fix with sensors to see if it could survive reentry. If a safe repair was not possible, teams would keep the damaged capsule for study. Later, they might set it on a controlled path to fall into the ocean. The quick unmanned launch showed how the program keeps backup options. The Zhochuan teams had hardware on standby so they could shorten prep time. Flight controllers, engineers, and medical staff worked together to make it happen. They ran through mission steps in simulations before launch and again after launch. All commands and procedures used clear checklists to limit mistakes. Those on the ground checked tracking and weather for the landing zones. They prepared the recovery team to meet the capsule if a return was needed. Recovery crews practice landing and medical checks for every mission. At the station, crew members moved some experiments to the new capsule as a precaution. They labeled tools and locked down items to prevent loose objects during docking and transferring work. Engineers used pressure cycle tests to see how the repaired seals might behave under stress. They recorded all readings and compared them to safe limits. Officials from the China Manned Space Agency briefed leaders at the Zhochuan Center and the Beijing control room. The move also highlighted the cost and complexity of crew safety. A small defect forced an extra launch, extra checks, and more planning. It used fuel, time, and money, but it avoided sending people into danger. What the teams did next will change how the program handles similar events. Wait until the next part to learn why small debris in orbit is becoming a bigger problem for all stations and crews. But as engineers traced the flaw back to its source, one detail emerged that no one expected: what was hiding in orbit. Why this matters: debris and safety. Space around Earth has many objects. Some are working satellites. Many are old rocket parts. Some are tiny pieces from past collisions. Together, they make a busy zone called low Earth orbit. Even small pieces can move very fast. When a small piece hits a spacecraft, it can punch a hole or make a crack. Like and subscribe.